So what is the main concept behind bubble sort? So it kind of treats every number as a bubble. All of you would have heard of it. Pairwise comparison. Yeah, very good. See, concept like bubble sort, see, whatever we learned in insertion sort, all of you might be knowing insertion sort and it would have looked very easy, but there are small details that you should heed to very properly, because in future these small details will help you solve the question. Okay. Okay, anyways, about bubble sort, same thing I am going to say for bubble sort also, same thing over here. This is a very brilliant sorting algorithm, and if you understand the nature of this, you can, solve many questions easily. Okay, so let us try to understand this, how it exactly works. So it treats numbers like bubbles. So let's say there is a big number like 50, and then there is 4, and then there is 17, and then there is 1. Okay, so this is a very big bubble. This is this kind of bubble. This is this kind of bubble, and this is very small bubble. So what it does, it compares bubble with bubble. So there are multiple rounds of comparison. Okay, this is the first thing that I want you to keep in your head. Okay, so this will be your first round of comparison. So in every round of comparison, all the adjacent elements collide with each other, and whatever is greater, that rolls over above the other. So what will happen when this rolls over the other? So first comparison was for 50 and 4 in the first round. The first comparison is for 50 and 4, and since this is bigger, so this will roll over. Why this is rolling over? Because the largest element should come later. So 50 comes here and 4 comes here. Now the comparison will be for 50 and 17. Okay, so 17 is smaller, 50 is bigger, so this is going to happen. And now again for 50 and 1 is smaller, so 1 comes here and 50 goes here. So this entire thing was round 1 of bubble sort. Okay, what is the important thing that we should understand over here? Let's see that. Few important observations are, after round 1, the first element will be, after round 1, the largest element will be at its respective position. Similarly, after round 2, what will happen? After round 2, if you perform a round 2, what is going to happen? You compare 417 and then 17 1. So 417, 4 is already smaller, so nothing would happen. 17 1, what is smaller? 1 is smaller, so 1 comes here, 17 comes here. 17 50, 17 is smaller, so no swap. So this was your round 2. Okay, so tell me, any round, I am talking about any one round, how many operations are involved in that? If there are n elements, can you tell me the time complexity of one round? For any round, what is the time complexity of that particular round? Order n, right? Because there will be order n mutual comparisons. Okay, cool. So if let's say there are r rounds, then the time complexity of bubble sort will be nothing but r into n. Right? Now we have to determine this r, that how many rounds are going to happen. Right? Okay, great. Another important observation over here is, in first round, let's say the largest element went at its deserving location, but for other elements their relative position was undisturbed. So this mutual collision ensures that the largest element of that step will go at its location, but for all the other elements that are still not sorted, their relative positions will be preserved. Right? Relative position means what? That if 4 comes first, then 4 is still first. 17 comes first, 17 is still first. 1 comes first, 1 is still first. And the same thing over here. So in round 2, the last 2 elements are sorted, so I am not even going to look at them. But for other elements, their relative position is preserved. So out of 4 and 1, 4 came first and 1 came later. So that is being shown over here as well. So after round 2, this happened. Okay, what about round 3? In round 3 again, you first compare 4 and 1, 1 is smaller, so 4 comes here. 4 and 17, 4 is already smaller, nothing happens. Okay, now is there a need to do round 4? There is no need, because now the array has already become sorted, right? Okay, so how do I determine that after how many rounds my array is going to get sorted? Is there a way to comment on r, which is the number of rounds after which my array would be completely sorted? See, first way is that I know for sure that in my round 1, the largest element will go at its last position, and whatever will be the last round, in that lowest element will stay at its position. So if I run n rounds, then my job will definitely be done. I never need more than n rounds for sure, right? So with n rounds I can get my job done. If you are running more than n rounds, that is stupidity. But one thing to understand over here is, and can you tell me in which kind of array the number of rounds will be equal to n? When the array is completely unsorted, when it is sorted in descending order, isn't it, guys? Yes, no? So the logic to that should be very simple, because let's say you had this. Can you tell me the output of this without applying this dry run? I can say it very easily. 5, which is the largest, will come at its last position, and this will obey its relative property. It will obey its relative position. So 4, 3, 2, 1 will be like this now. Now in the next step, what will happen? 5 remains wherever it is. Now the next largest is 4, so 4 comes at its position and remaining thing remains as it is. So on, you will see that after n steps, it would have become 1, 2, 3, 4, 5. So an important thing over here that I wanted to tell you was that I should be able to write my code in a way that if, let's say, after 3 rounds my job is done, then I should not go on to 4th, 5th and 6th round. Is there a way to do that? Is there a way to ensure that you write your code in such a way? Yes, you can have a flag or something to check. So let's say whenever a round has been performed, then you can run one more for loop to check whether the elements are sorted or not, and you can do that in order n. Okay, and if that is the case, you can simply break out and then your job would be done. So I will try to write one piece of code for this. You talked about flag, right? Which is going to tell me whether my array has become sorted or not. If that flag is false, that means it has not become sorted, so I need more rounds and I will be running those more rounds. Okay, so to initialize my flag, let me call that flag as done. So done is initially false. Okay, so while I'm not done, I'll do something. So listen to me very, very clearly. Let's say you are running some round, okay? Let's say after this third round you came to 4th round, okay? So in this 4th round, you will do these comparisons. Can you tell me how many swaps will happen in this round? 0 swaps will happen, right? So what I can do is that whenever I come inside, I transform my done to true. You will understand why I'm doing that, because after making it true, then I perform my round. In that round, if I see that any swap has happened, then I'll convert this done to false as a testimony of the fact that the array was not still sorted, right? So what would happen in such a kind of case where your array had become sorted as a consequence of previous round? Your done would have remained true, and because of that, when you come over here, your loop would be broken. Now everything else will be very, very simple. So every time I'll start, first I'll compare index 0 with index 1, then index 1 with index 2, then index 2 with index 3. Okay, so I'll start with index 0. Okay, and now I'm supposed to write something over here. So while some condition, I need to check one thing. What should be the condition over here? How many rounds of mutual comparisons are done? So number of rounds of mutual comparison is n minus 1. Okay, so first you compare 0 with this, this with this, this with this. You don't compare n with n plus 1, right? So I can say that while my I is smaller than n minus 1, what will I do? I'll check if my I, a of I, happens to be greater than a of I plus 1. If this is the case, okay, then what will I do? I will perform a swap of ai and ai plus 1. Okay, so I'll perform this swap, and is there something else that I'm supposed to do? I told you that if any swap has happened, then I need to mark this done as false to say that, hey, that the array is not currently sorted. So this done will be marked as false. So this is the if case things that I'm supposed to do, and otherwise I'll simply keep on incrementing my I. Okay, I think that's it. This is all about it. right? So this is the simple code for bubble sort that can do whatever we have learned so far, and then this will break whenever the array happen to be already sorted. Okay, cool. So what will be its worst case time complexity? In worst case, number of rounds could be n, where the array was in descending order, it would be n square, and best case time complexity? Best case time complexity will be order n, because immediately after the first round, you will see that the array was sorted and done will become true and never if condition would be true. So you can immediately break out. Okay, great.